What is sorbitol? Sorbitol is a polyol containing 6 hydroxyl groups with both a similar chemical structure to glucose and fructose. Sorbitol has the molecular formula C6H14O6, similar to both glucose and fructose's C6H12O6, and consequently, sorbitol can be turned and metabolized into both glucose and fructose at different points in time. And this is through either replacing the OH that are at multiple points along the sorbitol molecule with an aldehyde group if it is at the end in the glucose's case, or a ketone group in the sort of middle in fructose's case. Sorbitol, just like another polyol, xylitol, is a very, very sweet molecule, and it is present in some sugar substitute products, not as popular, and it's in not as many substitutes as xylitol is, and I'll get onto why that is in a few minutes' time. Sorbitol is metabolized and absorbed into the bloodstream a lot slower than xylitol is. So as I talked about in the xylitol video, xylitol can have laxative effects. It can be fermented inside of bacteria in the gut. It can draw in water from the bloodstream, and this means it has osmotic properties. This can cause things like diarrhea. Sorbitol is essentially a level up from this. It means that it will take less sorbitol to cause the exact same symptoms than what you need in consumption of xylitol. It does cause laxative effects. It does cause bloating, IBS, diarrhea, etc. if consumed in a moderate quantity, simply because of the amount of hydroxyl groups that it contains. It contains around, as I said at the start, 6 hydroxyl groups, which means that it attracts water. It can dissolve very, very easily in a solution, and because there'll be a high concentration of sorbitol inside of the gut as everything else is being broken down and absorbed, this means the water is going to be drawn in to dilute the solution, because there won't be as much water compared to the bloodstream inside of the gut. Sorbitol does not contribute to the normal 7 calories a gram that usual alcohols such as ethanol do, nor does it contribute to the normal 4 calories a gram that sugar and generally kind of sweet molecules contribute to either. It only contributes to 2.6 calories per gram, and this, just like xylitol, which contributes to 2.4 calories per gram, is simply because, one, it's not absorbed very well. Some of it doesn't get absorbed at all into the bloodstream and just comes out when you go to the toilet. But it's also different to xylitol because it goes through very different metabolic processes. Sorbitol is quite a rare molecule inside of the diet. While it's present in a few sugar substitute products, if you imagine xylitol, as I've said in my xylitol story when I was a kid, I used to have xylitol quite a lot. It's a sugar substitute, doesn't contain as much calories as sugar, doesn't contribute to the same sort of weight gain, same kind of symptoms that sugar does if consumed in an excess amount. There was these packets of xylitol. They were sort of green and blue. They had like the name Total Sweet, and it said xylitol sugar substitute somewhere on the packet. You don't get those kinds of things with sorbitol. There aren't packets of sorbitol because it has an amplified laxative and osmotic effect compared to xylitol, so you'll need a lot less for you to experience those pretty horrible symptoms, and this is why it's not marketed as much as xylitol is. It's contained in chewing gums. It's probably contained in a few sort of candies, things that are only supposed to be consumed in little quantities. They're not really things that are sort of bought in bulk like you would with granulated sugar, cane sugar, and like big bags of xylitol and stuff like that. It's not really found in that kind of form. It's found more in the processed foods. It can be found in nature, but it's still very, very rare inside of the diet. And if there is excess glucose inside of the body, glucose can turn into sorbitol inside of the body, and this is without sorbitol even having to be consumed. This is simply because there is too much glucose inside of the body, way too much glucose inside of the body for your body to actually process and manage and understand. So it has to turn it into all these various molecules to balance out how much glucose is actually inside of the body at any one time. And this is done by glucose and NADPH plus and NH plus, turning into NADP plus as well as sorbitol using the enzyme aldose reductase. Now this reaction ends up using quite a lot of energy. NADPH is a very useful molecule to the body. There is an entire sort of pathway that is sort of parallel to glycolysis that is dedicated to producing NADPH, the pentose phosphate pathway, which sort of goes off the side of glycolysis, that is dedicated to produce NADPH, which can be used for so many metabolic processes in your body. This is like an unnecessary use of NADPH. The usage of NADPH isn't necessarily a bad thing. Cholesterol, the production of cholesterol, which I've talked about before, that needs NADPH to actually be produced. But that is a beneficial and useful and necessary usage of NADPH, because it needs the molecules to turn into one thing from another thing, needs quite a high energy, and this means that NADPH, which is quite a high energy molecule, is used to help these molecules turn from one to the other. But the problem is that glucose to sorbitol, while being a high energy reaction where NADPH is needed, is just such an unnecessary reaction for your body to go through. So just cutting down on a tiny bit of sugar will mean that this reaction probably won't happen whatsoever, as it does happen in certain cells, which I'll get to in a little bit. And yeah, it will mean that you save on this little bit of potential and a little bit of energy that your body still has. But as I said, this reaction only happens in certain cells, and it's also a reversible reaction. This process only happens inside of the eye cells, the lens cells of the eye, as well as nerve cells. And because sorbitol, as I said, is a very osmotic molecule, it attracts water. This can cause a lot of damage to your nerve cells and your eye cells, because it will attract the water will osmose into places that it probably shouldn't. It probably would be better without, and this can cause some sort of damage. But even though the reaction of sorbitol to glucose would technically produce NADPH, a very high energy molecule, it's such an inefficient process that it just doesn't happen when sorbitol is consumed through your diet whatsoever. It is a reversible reaction, sorbitol to glucose, which would produce NADPH, but because it only happens in the cells of the eye, that's where aldose reductase, the enzyme that catalyzes this reaction in both directions, that's the only place that it's actually present. And so this means that the conversion of sorbitol to glucose could only happen in those places, which is such an inefficient way to go about things, because it means that sorbitol has to travel from your bloodstream while being metabolized slowly anyway, and then go all the way to the lens of your eye or the nerve cells, and then be metabolized there, which can be quite a seemingly risky thing. If you think about it logically, it would be quite risky to send sorbitol all the way to the lens of your eye just to be metabolized into glucose, where it could be easily metabolized into fructose by the liver. And this reaction is sorbitol and NAD plus turning into fructose and NADH using the reaction sorbitol dehydrogenase. Now I'm going to go a little bit off tangent and kind of explain the more in-depth and in detailed mechanisms of this reaction, even though I don't really have much of a script about this, and I'm pretty sure the way that NAD pluses, NADHs, and like H plus all work, NADH is sometimes represented and seen as NADH plus H plus, because it takes an H and then it also has an H plus on the end. Very, very, very confusing. But the way that dehydrogenase enzymes work is, if you imagine a sorbitol molecule and you imagine a fructose molecule, if you look at the difference, one of the OHs has been converted into an oxygen double bond. This means that two hydrogens have to have been removed, because if you look at the carbon chain, the carbon that's bonded to that OH, while it's bonded to two other carbons either side, it also has another hydrogen, because carbon can at most bond to 4 different molecules. It will take that hydrogen molecule that's lone bonded off for the oxygen to actually double bond. This means that the other hydrogen that was bonded to the oxygen itself also has to be taken off. That's where you get the 2 hydrogens from, and that can be either added onto the NADH and that, or like excreted as H plus, etc. But that's how a dehydrogenase enzyme normally actually works, because it dehydrogenases a certain and particular product. Hopefully I'm right, hopefully that does make a little bit of sense. That was kind of off script and off tangent, but now I want to go through a little bit of a weird thing, because sorbitol technically, if one molecule of sorbitol does actually produce more energy than what one molecule of fructose or glucose does. Fructose, just like glucose, produces 4 calories per gram. Problem is that sorbitol can be produced into fructose, yet the reaction from sorbitol to fructose does actually gain a little bit of energy. NADH can be used to make 3 ATP molecules, and then the fructose that contributes to 4 calories a gram, you have 4 calories per gram plus 3 ATP technically for sorbitol. But the reason that it's only 2.6 calories per gram being the key word here, is that sorbitol is so badly absorbed that it doesn't really contribute that much calorifically anyway per gram, because maybe around only half of that gram actually ends up being absorbed. The rest is just excreted as feces. But yeah, that's the reason that it doesn't contribute that much calorifically. But maybe per mole, maybe like per molecule of sorbitol, it is technically a better energy source than fructose or glucose. Maybe I'm wrong on that, But yeah, if I am, then please tell me in the comments, because it seemed like quite an interesting thing when I was doing my research, and I was very much caught out and confused when I was looking through these processes, yet it also said that it had a lower calorific value compared to glucose and fructose. But that's about all I have for sorbitol and its effects on the human body as well as its metabolism. And with that, I hope you enjoyed, and I recommend subscribing because I love this community of young tribal people who are willing to improve themselves so much more than they already have. And good luck.